Okay, the last video got cut out just a little bit. I was trying to finish up this problem with a little bit more detail that might help you on the assignment. It might say, what's the horizontal distance covered when it hits the ground? So when it hits the ground, that means, I shouldn't say I have a time as 0, I have a y value that is 0. Because that means the object is on the ground. So I plug in 0 for y. What you have now is your quadratic equation, which I'm going to go ahead and run the quadratic program on my calculator. So we've got -16, 65 sine of 45, and 5, and it spits out 2 different times. I know I can't have a negative time. That means my time is 2.9775, and it's looking for the horizontal distance covered. So 2 things. I could plug in that time back into this equation right here, or again, I could use my graphing calculator. I'm going to go into table. I type in 2.9775. It gives me my horizontal distance is 136.85. Okay, the last thing it might potentially ask you is, what is that maximum height? And remember, that maximum height is your vertex. And I don't think I have enough room there, so I'm just going to kind of squeeze it on down there. So you've got your vertex, which is at the top of your graph. Remember, you've got a formula for that. X equals -b over 2a. And my x value in this particular case here is my t value. So I'm looking at -65 sine of 45 divided by -32. And that's actually giving me the time. So let's get out of here. I'm going to go ahead and type that in. We had -65 sine of 45 divided by -32. And I get a time of 1.436. So let's go ahead and write that down, 1.4363. And as I said, technically that's the time. And I want to find the horizontal distance and the vertical distance. Well, that kind of goes along with this problem right here. When I had the time, I could figure out those values. Now this one we could do by the graph because I was counting by 0.5s, but this one is not a very nice decimal, so instead I'm going to use that option in my table. So let's go ahead and show you that then. I'm going to go into my table and I'm typing in that decimal, which again is stored in my answer. So I'm going to use that answer button, and it tells me what the horizontal distance covered and what the vertical distance covered is as well. So my horizontal distance was 66.016. My vertical distance was 38.008. As I said, I know that's more than what they've asked for, but I think that's going to be beneficial in a few other questions that you have. Okay, the last question is back to that Ferris wheel, which we can actually set up 2 parametric equations to show the, again, horizontal distance and the vertical distance as well. Okay, so for the last one, we've got 2 parametric equation. One is x30 cosine of theta. So if you look at this diagram over here, here is your theta, and we're looking for our x value right here. So if you look at that, we would have cosine of theta equals x over 30, which means x is equal to 30 times the cosine of theta, which is what we got right here. Now your y value would be here, and again, you would be doing sine of theta equals y over 30. So y equals 30 sine of theta, but you have to remember that you are adding on 40 feet right here because your radius is 30 and then you've got 10 additional feet. So that's how we're coming up with 40 plus 30 sine of pi. But we need that theta in terms of time. So if we look at that, you've got 2 pi radians for every 30 seconds. So the rate would be 2 pi over 30, which is pi over 15. So we're going to take these equations one step further. We've got x equals 30 cosine of pi over 15 times the time, and y equals 40 plus 30 sine, again, of pi over 15 times the time. Okay, in this particular one, we don't have to graph it. If you look at it, all they want to know is find Jane's position 22 seconds into the ride. So we could take the 22 and plug it in there, or if we wanted to, we could set these up as parametric equations in our calculator. So let's go ahead and do that just to get that practice. So let's clear out both of those equations. We've got 30 cosine of pi divided by 15 times the time, and 40 plus 30 sine of pi divided by 15 times the time. And again, we want to know 22 seconds in. So I'm just going to go into my table. It's already again set up on Ask. And let's go clear out all of these other ones. Those are from other equations, and we have a time of 22 seconds, and it gives me, again, my x value and my y value as well. So we end up with x is equal to negative 3.136. My y is equal to 10.164. And if you think about the 22 seconds, that would be roughly over here because it takes 30 seconds to go all the way. Here would be 15. One revolution every 30 seconds. So 22 seconds would be down in here, which would make me think I've got a negative y value, but that's not what it's telling me. I guess because I'm still 10 feet off the ground, I was thinking my origin would be here. So the 10 makes about sense because this is 10 right here. I'm a little bit greater than that. Again, this was a time at 22 seconds. Okay, couple things. This is probably more difficult. This one is exposure. You're only going to see one of those questions on Math Excel. As I said, you've got to get on and at least start this. That way we can get on and Zoom and get some things cleared up for you as well. And again, check that calendar to see when that quiz is going to be later on in the week. Thanks so much. Bye-bye.